Hi, I'm Chiviken. We'll be talking about soil consolidation. So, what is soil consolidation? Soil consolidation is actually the reduction in volume of partially or fully saturated soil. What do I mean by that? The reduction in volume due to an applied pressure, on a soil. So your soil is actually fully saturated or partially saturated. When you apply a pressure on it, there will be a decrease in the volume of the soil because of what? Because of the pore space in the soil, because of the voids in the soil, because of the water contents in the soil. So this particular contents reduce because of this pressure. So this pressure is what the soil consolidation is talking about. How does the settlement occurs in real life scenario? What I mean by real life scenario is using your building as an example. You as an engineer who is on site, you are working on site and there is a saturated soil in your site. Now, when you place your building, there will be a settlement after a long period of time. That will cause cracks on the buildings. So these particular cracks are the things that made up of this soil consolidation. So these cracks are the settlement. So when you see some of the cracks, we have the uniform settlement, we have the differential settlement, which is where the cracks comes out from. So we have three stages of soil consolidations. We have the primary consolidation, the secondary consolidation, and we have the initial consolidation, the primary consolidation, and the secondary consolidation. The initial consolidation is the preliminary settlement, the first decrease in the volume of the soil. While this primary is the one that takes a long period of time to settle. That particular one decreases the volume to a particular point, while the secondary takes over from there, making sure that there is no longer any void or pores on that soil. So we'll look at some examples, both the one from the field and also the one from the lab. We'll first of all look at examples from the lab, answer the questions from examples from the lab, and then we'll also refer you to the one from the site. So for example, we'll have a question here that says, find the time required for 50% consolidation in a soil stratum 9-meter thick with previous strata on top and bottom. Also determine the coefficient of consolidation, given that K, that is the coefficient of permeability, is equals to 1 times 10 raised to the power minus 9 meter per second, a void ratio 1.5, and the AV, which is the volume of compressibility, is equals to 0.003 meter square per kilonewton. So we'll first of all answer the first one, then we'll go to the second question. So the answer to the first one, we have the question, and the first thing you're going to do is to bring down the formula to solve. So after the formula, then you go ahead with other things. So you bring down your parameters. What I mean by parameters is the things that you are going to use in solving. So we have to find the coefficient of consolidation using the formula first. So CV is equals to K all over MV gamma W. We know what gamma W means. That is the unit weight of water. MV is actually the volume of compressibility, while K is the coefficient of permeability. Then our CV, we know what CV is already. So with the help of our AV, we can be able to get our MV using the formula MV is equals to AV all over 1 plus EO. So EO is your void ratio, and AV is the a volume of compressibility as well. We have it as 0.003 meters square per kilonewton. MV is equals to 0.003 all over 1 plus 1.5, which will give us 0.0012 meters square per kilonewton. Now with that, we can be able to solve our CV and be able to get the coefficient of consolidation, which is 1 times 10 raised to the power minus 9 all over 0.0012 times 10. That will give us 8.33 times 10 raised to the power minus 8 meters square per second. Now, to get the time required for 50%, as that was what the question says, we should record that there is also another formula for coefficient of consolidation, which is CV is equals to TV d square all over T50. TV is actually constant for 50%. So they have many, we actually have more TVs for 60%, 70%, 80 and 90% as well. So, but for 50% of consolidation, we'll have TV to be equal to 0.20. Then our D, that is the depth of the soil, is actually 9 meters. But because it is previous top and bottom, that means it drains top and bottom. We are going to divide the thickness by 2, because that means drainage occurs both at the top and as well at the bottom. So our CV, our D will now be 9 over 2, which is equal to 4.5 meters. That will give us, we'll substitute 8.33 times 10 minus 8 equals to 0.20 times 4.5 raised to power 2 all over T50. Or cross multiply. T50 times 8.33 times minus 8 is equals to this 0.20 times 20.5. 8.33 times 10 minus 8 T50 is equals to 4.05. T50 is 4.05 all over 8.33 times 10 minus 8. That will give us our answer in seconds. Your answers will be in seconds. Reason because your CV is in seconds. If your CV is in meter per minute, then your answer will be in minutes. If your CV is in meter per seconds, then your answer will be in seconds. So 4.05 is actually the one we got from 0.20 times 20.25, which that particular place is already in meter square all over 8.33 times, which is, this one is also in meter square per second. So when meter square cancel meter square, you have seconds to be your unit. So T50 is equals to 48,619,447.8 seconds. Then we have to convert it to years. So let us know how many years it takes for this settlement to occur. So T50 is equals to 48,619,447.8 seconds all over. Do you know that 60 seconds make 1 minute, 60 minutes make 1 day, 24 hours make 1 day? That means 1 day in a year is 365. When you times it, it will give you a value. Then you divide it with the seconds, you will be having 1.49, approximately 1.5 years. So that is the years it will take for that particular thick soil to settle, right? So that is the answer for that particular question. If you have any question, drop it in the comment section, and don't forget to follow us. Thanks.